So what do they find out about Oumuamua? And has any satellite been able to track it down and predict where exactly it will crash? Chapter 2. Theories around Oumuamua. Various theories emerged to explain Oumuamua's identity. First, some believed it was a rock. Others proposed that it was filled with gas. But then, some experts astonishingly said that Oumuamua must be an alien aircraft. This raises the question of whether an alien ship is somewhere hiding while releasing a part of it to explore the Earth. But is that the truth? Let's dive deeper into the theories to find out more. According to Dr. Mech, Oumuamua must have been flung from a distant star following a supernova explosion. According to Elon Musk, it was formed when two objects collided and fused together. Astronomers were initially happy when they discovered that Oumuamua seemed to point toward Vega, the brightest star in the Lyra constellation. This star was known to possess a debris disk. By calculations, this object might have traveled to the present location in roughly 600,000 years. But then, the possibility of it coming from Vega didn't hold much water. That's because significant changes were noted in its path. Astronomers believed that Oumuamua must have encountered a new star system for the first time, considering its motion around the Sun. This was similar to the speed of nearby stars. Nonetheless, there's a possibility that Oumuamua must have been around the galaxy for billions of years. Another theory worth noting suggests that Oumuamua is a chunk of nitrogen ice. According to researchers Alan Jackson and Stephen Desch from Arizona State University, Oumuamua might just be a fragment blown off a Pluto-like object by a massive impact. However, to merge with this theory, Oumuamua would have to be smaller than initially thought. Another theory proposes that cosmic rays interact with surface ice in interstellar space, freeing hydrogen gas trapped in water molecules. This created a supply of hydrogen gas trapped in amorphous water ice. This is the theory from Daryl Seligman from Cornell University and Jennifer Bergner from Berkeley University. They suggested that Oumuamua gained warmth from the sun, which altered the structure of the ice and pushed it forward. Well, this may be true only if it was truly an ice. But that's not all. Astronomers Avi Loeb and Shmuel Bialy from Harvard University suggested that Oumuamua could be a solar-powered spacecraft. That sounds interesting. According to them, the various characteristics of Oumuamua suggest that it has an artificial origin, hinting at the possibility of extraterrestrial origin at play. This lends credence to the assumption that Oumuamua might be from an alien. No doubt, the appearance of Oumuamua lends credence to the fact that it originated from a place outside our understanding of the solar system. However, we can't draw a final conclusion because its true size and shape remain a mystery, and no device has been able to capture the actual image of this object. Astronomers only rely on its brightness and their knowledge of how asteroids and comets reflect light to guess the size. However, since no tail or coma had been found on the object, the comet theory was not approved. The comet theory also suggests that Oumuamua's apparent movement could be from the force that broke it free from a supposed parent object. However, repeated non-gravitational acceleration contradicts this assumption. In place of that, scientists coined a theory involving sunlight. If Oumuamua is extremely thin, around 0.3 to 0.9 millimeters, its movement could be due to solar radiation pressure. They proposed that Oumuamua could be a light sail, a technology demonstrated in space missions like the Japanese probe and NASA's NanoSail D2. These light sails use photons' kinetic energy to propel themselves through space. Therefore, they suggest that Oumuamua could endure a long journey through interstellar space through a light sail. They estimated it could travel at least 16,000 light-years from its home system, wherever possible. Additionally, Oumuamua's motion closely aligns with a region of the Milky Way galaxy called the Local Standard of Rest, making it difficult to establish its origin.